Okay. So here is what we did yesterday, I guess. Here's a review of what we did yesterday, right? We learned first about law of cosines, and we talked about how it only works for side triangles and side angle side triangles. Okay. There's your three different formulations. Again, the only one you'll be given on tomorrow's quiz is that first one. Okay, but you can derive these other two just by manipulating that first one, right? By kind of flipping the letters around, right? Instead of a c squared, you put b squared there. That leaves a squared and c squared to ac, and then cosine b. All right, and it's just flipping the letters around. That's all. Okay. Again, here's an example of when we had side angle side. All we did was solve for the opposite side there, but again, we could use the law of sines for the rest. So no need to continue. All right, and then I'll show you one more example here with a different situation. So now again, let's solve the triangle. Okay, and using the given information. And let's say that we've got our triangle here, ABC. Okay, and yeah, let's get a right triangle, but it's not supposed to be. Anyway, this is not drawn to scale. Not drawn to scale. So we'll say that side A is 7, side B is 10, and side C is 4. So yes, definitely not drawn to scale here. Okay. So, side situation. Law of sines here would not work. Why can't we use law of sines to solve a problem like this, the way it's written right now? Why will law of sines not help us here? What's the problem we're going to run into? Sean? We have no angles, right? In order to use law of sines, we need to have an angle and opposite side pair. Any setup, any formulation of the law of sines that we try and set up here is going to have two unknowns because we have no known angles. So all of the setups will have two unknowns, two unknown angles in this case. All right, so we have to use law of cosines. All right. So the question is, which should we solve for? Should we solve for anything? All right. The recommendation here, the suggestion, is to solve for the biggest angle first. Okay, so that's the key thing to remember here, is solve for the biggest angle first. Solve for the biggest angle first. So, which angle here is going to be the biggest angle? We don't know any of them. Devin? How do you know?
Because it's got the biggest side.
Yes, exactly right. Okay. Triangle inequality theorem, which you don't need to know the name, but the principle is important to know. The biggest angle in a triangle will always be opposite the biggest side. The smallest angle will always be opposite the smallest side, and the middle size angle will always be opposite the middle sized side. Okay, so yes, angle B is the biggest, so we're going to solve for angle B, which means we're going to use which of these three formulations of the law of cosines here. If we want to solve for angle B, which one do we have to use? First one, the second one, or the third one will help us solve for angle B. Which one? It's got to be the second, right? It's the only one that's got angle B in it, right? It's got to be number 2. All right, so B squared equals A squared plus C squared minus 2AC cosine of B. All right, so we'll just plug stuff in here. So let's see, little b is 10, so we can say 10 squared there. And then let's see, little a is going to be 7 squared. Little c is 4 squared. Minus 2 times 7 times 4. Cosine of b. Okay? And for whatever reason, solving this equation messes up students. Okay? Like, this is algebra, but it messes people up, the format or whatever, and I think it's because we forget, like, maybe our order of operations, or forget how things can combine, how things can't combine. Maybe it's the cosine throws people off. So, you know, if you're like, I got this is algebra, you might not get it. Okay? If you're like, oh, this is easy, It might not be easy for you, okay? So you may want to follow along here. And again, I would suggest you take it in a couple steps here maybe, all right? So I'm going to make this 100, okay? What things can we combine together here right off the bat? What things can go together? For example, I can square the 7 squared. I can square the 4. So let's see, I get 49 and the 16 minus, and then the 2 and the 7 and the 4 there. So I went ahead, I'll just square everything. Okay? But what things can go together over here on the right-hand side? What can we kind of do next here?
Multiply.
Now I've scared everyone, right? So what? Go ahead.
Multiply 2, 7, and 4.
Yes, and only the 2 and the 7 and the 4, right? So, okay. And also, what else can we put together besides the 2, the 7, and the 4 and multiply those? What else can go together?
49.
49 and the plus 16, right, okay. So 49 plus 16 is going to give us 65. 2 times 7 is 14, times 4 is 56. Okay? And then we subtract the 65 minus the 56. No. No, we do not. Okay? Why can't we subtract the 65 and the 56? 56 has got a cosine b next to it. 65 and 56 are not like terms. Mr. Whitmire, they're numbers. Yes, they are numbers. And numbers are like terms, but the 56 is a coefficient of cosine of b. So you can't put those together. And I think that's where a lot of mistakes are made. I feel like I see students type in this mess right here, the 7 squared plus 4 squared minus 2 times 7 times 4. They get a number and put that in front of cosine. But that's not right. These two can go together. These three can go together. And then you solve from there, okay? So please don't put these two numbers together. Subtract the 65 from both sides, and so we'll end up with 35 equals negative 56 cosine b, and then divide both sides by negative 56. So you get cosine b equals 35 over negative 56. Okay. You can obviously skip more steps, okay? I'm really writing it out explicitly. This is our first time doing it and stuff. You can skip steps, but be careful, please. All right, because when you make this mistake, it throws off your entire triangle here. All right, so anyway, we do cosine inverse of both sides. We get about 128.682. No, this is like our notes. We're into our notes now, because we were just continuing on from yesterday's. I didn't like do a whole new sheet. I just started off from yesterday's because it kind of continues. Okay. Now at this point, what can we use to solve for the rest of the triangle? Law of sines. From here on out, law of sines. Please don't try and use any more law of cosines. Okay? In fact, we only need to use one more law of sines. It doesn't really matter which angle you choose to solve for. I'm going to just solve for angle A here. Okay? So let's just do angle A. So I'm going to pick somebody here for that, actually. Let's go to... So what would be, Megan, our setup then to solve for another piece? What can we do now from here?
So you have, wait, we found the angle B.
We got angle B. Yes, sorry, you might be ahead of me now.
Do the sine of 128.682 divided by 10.
Okay, all over 10, and that's going to equal what?
Do sine of A divided by 7.
Perfect. Okay, cross multiply and solve for sine of A, and you get 7 sine of 128.682 over 10, and then we take sine inverse of both sides. Over 10, and you get 33.123. Okay. No need to check the ambiguous case here, because again, we're guaranteed a unique triangle. All right, and we can find angle C. Should we use law of sines to find angle C? No, we got two angles. Just subtract from 180. So 180 minus 31.123 minus 128.682. And we get 18.195. Okay, and so there's our final measure. And again, depending on your rounding, your three angles may not add up to exactly 180 degrees, although in this case they should because of the way we calculated them. They should. Well, yes, it should add up to 180. Yeah. Okay. Questions on any of that? All right. So then I've got some more for us to try here. Let me see. Okay, so actually, let me see. I'll do this one. I'll do the bearing one. I'll give you one. Okay. All right. So this problem is taken straight from our practice benchmark. Okay, this problem is taken straight from our practice benchmark. All right. Practice benchmark, not actual benchmark, right? Can't show that. But this is very much in the nature of the kind of problem you'll see on it. Let's type that one. What is this? So this is the problem we're going to work on. I'm going to help you guys set up, and then I'll let you guys kind of solve here. All right. So, half the battle in this problem is, first of all, understanding the directions and being able to draw the diagram so that you can then solve it, right? So, number 2, which is the only one, I don't know why it's number 2, but there it is. And we'll see this exact problem later when we actually start practicing with the benchmark. So, anyway. A fishing boat heading due south is about to turn towards one of two docks. Dock 1 is located at a bearing south 55 degrees west of the boat. Dock 2, 10 kilometers due east of Dock 1, it has a bearing of south 32 degrees east of the boat. Round on calculations 3 decimal places. Okay, so this is worth a total of 7 points. So part A, drawing the picture and labeling with the information provided, that's 1 point. Okay, so since the boat is heading south, whereabouts should I put the boat in my little space here? At the top, right at the top, because it's heading south, so we want to give it some space to kind of draw the rest of our work here. So I'm going to draw my boat. It's, obviously not aimed towards the south, but there it is. Okay. My boat's a sailboat. All right, now, again, we'll assume, and you guys can orient your papers however you want, but for whatever reason it seems most comfortable, I think, to probably have it oriented so that north is up, east is right, west is left, and south is down, right, on our paper. You can orient it however you want, but I think this, with the way we put our boat, we should probably orient it this way. Okay, most comfortable. Okay, so Dock 1 is located at a bearing south 55 degrees west. So I'm going to draw in a dotted line here that represents the direct south bearing. Okay? Because the boat's kind of headed on that path, but it's going to turn here towards one of the docks. Okay? So if Dock 1 is south 55 degrees west, does that mean it's going to be to the left or to the right of this dotted line? Left. Why left? Because that's where west is. Exactly right. Okay, so we're going to open up from this angle here. We're going to go out. I'll draw a solid line as for this piece. Okay, and so this angle right here, that's where that 55 degrees goes. It's south, but 55 degrees west. Okay, and we'll say there's Dock 1. I'm not going to draw a picture for Dock 1. I'm just going to put a point. Okay. Dock 2, which is 10 kilometers due east. Due east, which means straight across. Not up, not north or south of it, due east, so directly east, right? If you were to get your compass out and look in the eastern direction, okay, Dock 2 would be right due east from that. So 10 kilometers due east, I'm going to go straight horizontal right here to Dock 2. Okay, and then the whole thing here, that is 10 kilometers. that distance is 10 kilometers due east of dock 1. That's dock 2. Also, it has a bearing, south 32 degrees east of the boat. Well, now with the way we draw in the picture, it's kind of obvious, right? Here's the southern direction. 32 degrees east then is going to go to the right. Ugh. Okay, and so then there's 32 degrees right there east. Okay? So, there's our setup. Questions on any of that? So I want you to answer letter B then. Or go ahead and try to answer B based on the information we've got there. Okay? Which dock is the boat closer to? How much closer is the boat to this dock than to the further dock? So what's the difference, right, in their distances? So go ahead and find the distances from the boat at its current position to dock 1 and dock 2. Okay? Yes.
Is this a 90-degree angle?
That will be a 90-degree angle down there, yes.
On both sides?
Uh-huh.
That was a dumb question, but yeah.
No, not a dumb question, but I mean, it would be, yes, it's a
On
straight
this
line,
side,
so
yeah.
I see what you're saying. I mean, you know. Yeah. So, that's a good question. What do you think? So if you're saying, you're asking, is this equal to this, basically? So, if that were true, that means these two triangles would be congruent, because you would have then a side, well, I don't know about that, let's see. We don't know if isosceles or not, so I wouldn't assume it is. Let's say that. I wouldn't assume it is. So again, think about this here, how you would solve it.
Send me a picture.
Just to try to think about how you might set this up. So, this 10 kilometers is a measure of, so right idea of what? This 10 kilometers is a measure of this bigger triangle, and then you're using the right angle on the smaller triangle here. See what I'm saying? So, 55 degrees is not opposite 10, because this measure is only. Do you see what I'm saying? So, so 55 and 45 would be 90 here, and then that's opposite 10, which you can then use this angle to that side. See what I'm saying now? So it's a, think bigger triangle, these bigger triangles, not both smaller triangles. Yep.
Can I borrow a calculator?
Mhm.
Wait, if this is a right triangle, can I use this? Like, to find an angle?
Yeah, yeah, yeah. Mhm. Mhm. Use our calculator instead. Yeah. Okay. You're welcome. All right, so let me give people just a little bit more here because I think we can maybe benefit from just having a bit more information. Okay? So, this line right here, this imaginary line, it's running which direction? North-south. This line right here is running which direction? East-west. So that means north-south, east-west. What should the angles be here? 90, or right angles, right? Okay. Which, if we then look at this not as one big triangle, but if we look at it as two smaller triangles, okay, what's the measure of this angle, or how could we find it? And by the way, Julia, I think you put down 35, but it's a 32 here. So that's going to affect things, so sorry. How can we find this third angle right here? Yeah, 90 minus 55, or 180 minus 90 minus 55, whatever you want to say there. So yeah. So 35 here. And then 90 minus 32 for this one, so 58. And now if we go back to the big triangle here, where the two triangles kind of together, okay, big triangle here, we have a 35-degree angle, which is opposite y. We have a 58-degree angle, which is opposite x. And then we have, what's this measure? 87, which is opposite the 10. And so maybe use that to help you out there. Okay, so give that a try now. Give that a try. Okay.
We're trying to find X and Y.
Find x and y, right? You want to find the distance from the boat to those two docks. Okay, find the distance from the boat to those two docks. Find the distance from the boat to those two docks. So the problem with this is that we don't know that that splits it in, this splits it evenly to 5 and 5. So you want to use your bigger angle 87 and then the 10 and then use that. Okay. Good thinking, but we just don't know whether it does it. Yeah. Yeah. Okay. So you see what I was saying there. So all you got to do is just change. So erase that. Okay, and erase that. Yeah, you just have to erase. Well, actually, you have to erase the whole
Are you
thing.
using
Okay.
Law of
So then,
Cosines?
yeah.
Yeah, I am. I know you're using it.
Yeah, you have to erase the whole thing, basically. Okay. That's okay though. Got it?
Very good.
I hope so. Okay, that's looking like the right idea there. Okay, I see that. Yeah. So how much closer? It says it's closer, but how much closer? So I know, right?
Like add these two angles together.
Yes.
Okay.
Yes, yes, and exactly that's what you need to do then, right?
Yeah.
So then you're going to use the big triangle here. So you have to use the two smaller triangles to get these, and then big triangle then to start solving.
Okay.
Yeah. Okay.
Bless you.
Okay. So you see, we know this angle now though. So you can use that to help you from the triangle there. So. Okay, sorry. I thought that was like, I thought you were like 5.8. I was like, where'd you get 5? Because it's sine. Okay. Okay. So, yeah. And that's how I know it's 87 over x. Yeah. Okay, good. And then you do the same thing for that one. Okay, good. Good. Yep. That's a good idea. Do you need a calculator, Brian?
No,
Okay.
we're supposed to get like how far, like how close it
What
is.
did you get?
Yeah.
How much closer? So you have your two distances.
What?
So that one's closer, but how much closer?
This is one distance.
Yeah, dock two.
Another one
Is
is
that by 2 points?
dock two.
I see what you're saying. Okay, then yes,
Yo,
yes,
I
yes,
can
that's
I
see
what
my
got
you're saying.
it's
calculator. Hold on, bro.
5.7444
Yeah, but then it's closer by 2.748 feet.
I got it. Calculator.
My two distances are 5.744 and 8.492.
You got 8.492. I got
Yeah.
7.671.
I
Hang on
got
a minute.
8.492.
Okay, so I did something wrong. You're making this close. I know. How did you do that?
37 centimeters.
What'd you do?
So yeah, I was going to say, if you feel pretty confident about letter B, try reading letter C, okay? It's in addition to the diagram that you make there. Okay, so you feel like you did okay in letter B, you want to try in letter C. It's in addition to the diagram, and so you want to, try see if you can add it on there correctly. Yes, that's looking good. Good job.
He got 8.4.
So again, if you want to try to
Yeah,
move on here.
27.
You guys got one more minute, and then we'll take a look at letter B. Okay, and talk about letter C as well.
Look at these angles. What did I do wrong?
You might have just divided it wrong.
Oh wait. Was the 5? Did you get 10 times 504? Oh, I put the wrong number. Is what I did wrong.
Yeah, I did it like so unnecessarily actually.
Okay? So, here's the solution for B. All right, there's that solution for B. All right. So, within this diagram here, we have three triangles going on, right? We've got the right triangle, and then this big non-right triangle. Okay? We need to use all three to help us solve this situation. We need the smaller right triangle to get this 35-degree angle here. We need the smaller right triangle to get this 58-degree angle, but then that 35 and 58 are also part of the bigger triangle here. Why do we need to go back to that bigger triangle? Why can't we solve the smaller triangle? Because in the smaller triangle, we don't know any of the sides. Ms. Whitmire, if this is 10, then this should just be 5, right? It would be if these two triangles were congruent, but it ends up, we don't know if they're congruent or not, right? We can't say that this is 5 and this is 5. Okay? So instead, we have to go back to the big triangle, where we know that the full angle here is 87, which is opposite 10, and then use law of sine. Sine of 87 over 10, and then solve for the other two lengths there. And so you get this answer. Dock 2 is closer to the boat by about 2.748 kilometers. Okay. All right. Show you one more little thing here. So then letter C says a dock worker spots a swimmer hanging onto a buoy that is 3 kilometers away from dock 2. So we're talking from dock 2, the worker's on dock 2, and it spots the swimmer there. Okay? The buoy has a bearing of north 18 degrees east from the dock. So let me put this in a different color here. So from dock 2, north 18 degrees east. So north, and then 18 degrees east, and we're 3 kilometers away. Okay. How far would the fishing boat have to travel to rescue the swimmer? So here's where the swimmer is. And here the fishing boat, it hasn't moved still. And we know, let's see here, we know that this y is 5.744. Okay? And so we want to know this distance right here. We want to know that distance right there. We know this side, so again you can see we have a triangle here, right? We know this side of the triangle, 5.744. We know this side of the triangle, 3 kilometers. We know part of an angle here, 18 degrees. Could we find this other missing piece right here? And if so, how? Again, remember, this line's running north-south. This line's running east-west. So, Deb? Yeah?
It's like a parallel line thing.
Yeah, it's another parallel lines thing.
Transversal.
So, we could, let's see here. Would that work?
I don't know.
I think, yes. Yes, it would. So what would this angle be?
32.
32. It's alternate interior to the 32. Alternatively to that, right, the east-west and the north-south, this is making a 90-degree angle right here. So if that's 58, you can subtract that from 90, and it'll still also be 32 that way as well. But no, you're right. They are parallel lines with a transversal there. So yeah, 32 degrees. So we know the full angle here is 32 plus 18, so that's going to be 50 degrees. The full angle is 50 degrees. So now what should we use here to find this length? Can we use law of sines? Do we have an angle and opposite side pair? We have a side, an angle, and a side. So what should we use here? Law of cosines. You got to use law of cosines. That's right. Okay. So law of cosines, and let's see here. We're going to use since there's no A, B, and C here, it's kind of hard to determine which one it is, but we'll use the formulation where, again, we have this angle. So I'm just going to say that, I don't know, I'll just call that C squared. So C squared, we're trying to find this side length here. We know the A is 5.744. We know the B is 3 minus 2 times the 5.744 times the 3 times cosine of, and then we said that was what, 50, right? Yeah, 50. Okay, and then you solve from there. Okay. I'm going to stop there, though, because I want to get you guys time to start on your assignment. You got the 15 minutes here, so I'm going to make sure you guys get time to start on your homework. Okay. I would like you to try and finish this up, just to kind of see that you can, finish and solve accurately there. So do try and finish up letter C. And I also have some book problems for you to try here. Okay. There will not be any word problems on tomorrow's quiz, but there could be on the test. Okay, so not necessarily on the quiz, but possibly on the test. So heads up on that. Okay. And again, there's a very good chance you'll see a question like this on the benchmark too. So, but we'll get more practice in, so don't worry if you're like, oh, I don't understand. Okay. All right, page 441. Numbers 7, 9, 19, 31, 47. This is a change from the calendar. This is a change from the calendar. I changed from 46 to 47, and then number 52. Okay? Please use your calculators for this stuff. Okay? 47 is one of those bearing questions. It's not quite as complex as this one is, but it's still a bearing question. Okay? Bless you. So let's go ahead and get those books cracked open and get started on these. Make sure you're doing this right. Okay, again. Especially since some of us maybe didn't do as well as we wanted to on the last quiz. So now here's an opportunity to, bring that average up some, right? Sean, any questions for me? Say one more time. What do you want in the actual solution? Let me check. I'll go.
Okay, bring barbarian period again.
Are we done with this? Did we do C?
We did see. We didn't solve it.
And again, yeah, don't forget there's also the problem set too that you guys have.
Like, they're all just kind of the same.
Thank you.
Bring your book. Bring it.
And there's like 3 different subjects in it, which is kind of funny.
Right. Oh. This looks like.
You have to read the story about being arrested.
Oh. I see some math in there, so.
No, there's a story about stealing polo shirts.
Oh, yeah.
Crikey.
Crikey.
Crikey. Oh, there's some Latin in here too, it looks like.
So there's this 47
Oh, I see whose it is, okay. Yes. Alright, sorry Sean, I got like approximately 4.454.
That's what I got.
Julian, just accept it one day.
Kilometers.
Every day I drop a
Why?
and every day it surprises him and he goes, stop.
How are you?
Danny, I still need to get you in to finish up
You know why I
this,
lose
right?
this
So
game?
I'll do that.
Because I'm always on offense and I try to attack. And then I end up shooting into a hole in one.
How did they do, Abby?
I mean, like, what do you think is good? I only think I've gotten for like a 7.
Okay, 7's still pretty good.
Yeah,